calculations will become easier. This is a fixed here. So there's a small particle I'll release on the y-axis at a distance 4l. By the time these are fixed, they will not move. No? So by the time when it crosses the origin, what is the speed of that particle? I'll release it from rest. They're the very simplest ideas. Okay, now, so what are the forces that will be acting? Oh, sorry. This is 2m. Symmetry will not be there. No? Yeah. Now, get into the problem. So how the forces they'll be acting? Take help of the force that one. So the force between them will be in this direction. The force between the particle and the 2m will be in this direction. So resultant force, how it will act along the y-axis, so it will start accelerating. What was my question? My question is like, find the speed of the particle when it reaches the origin. So now, what type of motion this particle will describe? Shall I say variable accelerated motion? Sir, why variable? So now when a force will act. So as it comes here, look at the force. It depends also on what? The suppression and also that angle, no? Means all time it will act along y-axis only. All the time it will act along y-axis only. The force will be directed, the net force will be directed along y-axis. So now as it starts moving, what will happen to the force of interaction? The force of interaction will increase. So what type of motion to describe here? An accelerated motion, uniform or non-uniform? Non-uniform accelerated motion. So then how to work out that one? Very complicated. If you want to try it, I'll leave it to student, because as a teacher, I should not show everything. At least I should allow something for you to think. So you do one thing. I give distance 4l. So when the particle is at a distance, say here, 3l from the origin along y-axis, calculate the force. When it is at a distance 4l, calculate the force. When it is a distance l here, calculate the force. The force acting on this particle is continuously varying. So how to calculate the speed? If you go for kinematics, it's a very lengthy problem. So I am simplifying what? With the help of the interaction potential concept here. So what is initial energy plus Ki equal to UF plus Kf? Initial interaction potential. Interaction between what? So this will be G M2M phi L. Then interaction between this particle and this mass 2m. And there'll be also interaction between these two. Actually, I'm writing it. So this will be 6L. And they're fixed and this release from rest. Final interaction potential G minus Gm 2m by 3L. You look at this interaction. What is this interaction? It will cancel out, no? So the interaction between the particle and these two particles, between say like a M to M, it is this one here. What is the separation initially? Phi L. Finally, what is the separation between M and this 2M, the left particle? It is 3L. Solve for this, you'll get the V naught. It's no need of any mathematics, no. Or else what you should do? You should calculate the force acting on it when it's somewhere here at arbitrary point. Then that force as a function of distance y will come. Then you should integrate. Then you have to work out. So what is the advantage of energy concept here? To minimize mathematics, finish over, nothing big. If I do 1,000 problem, if I do one problem, if I do 10 problem, what is the core idea? To minimize mathematics, this energy concept is introduced here. So simplifying further, this will be minus gm square, and this will be send it on that side. So this will be 4 minus 4 by 5 plus 4 by 3 G M by L B naught square by 2. Anybody value? This will be 12, 12, 8 by 15, 16 by 15, I think it will be. I check once. So this is the speed of the particle. I think this, oh no, finished, no integration, nothing. Agree this? Okay, we'll take one more question.